So after we understood about how this matplotlib works, now it's the right time to talk about Seaborn, which is another variant of matplotlib. In fact, Seaborn is built on top of matplotlib, and this is more effective because you can create even more attractive plots using Seaborn, and in fact it's going to be more concise than your matplotlib. You can add colors, you can customize your plot. So all these things are possible in your Seaborn package. Now, in order to work on your Seaborn, you need to again import this Seaborn package. If you don't have it, you need to definitely go ahead and install it once again. Now, in this case, I'm going to use a data set which is coming from market_fact.csv. Once I do this, we are going to now look at some Seaborn analysis. Now, while understanding this Seaborn, I'm also going to take you to a univariate analysis concept as well. In fact, this univariate concept is going to come in much more depth when I will be talking about exploratory data analysis. But for now, uh, at least using Seaborn, you will get some more insight that how this gonna looks like. Now, so what I'm gonna do, there is a column called as shipping cost. Means you have to look at it from, let's say, Amazon or Flipkart point of view. So when they ship you some project, this includes some sort of shipping cost for them. So let's say what we want to do, we want to have some analysis on that particular column. Let's see that how the shipping cost is kind of distributed. Now, what we can do, we can use this sns.distplot. What does distplot do? This distplot is going to return you basically a distribution of your data. So the output will be in form of probabilities. Okay, so because it is a distributed plot, what it's gonna create for you. Now, you can see here, so it's gonna create a density curve, which is basically ranging from 0 to 175. But on the y-axis, if you look at, we have a probability term, probability ranging from 0 to 1, right? Now here you can see that most of the values are falling in the lower range. So maybe what is happening here, that if you think from Amazon point of view, maybe we do have items, most of the items which have basically lower shipping cost, right? Maybe because if you order a fridge, definitely the shipping cost for that fridge is going to be higher in comparison to if you buy, let's say, a book. So that's what this is going to tell me, of that the probability that we have a lower shipping cost for a particular product is higher. But this is also giving me a good insight that how the other distribution is also looking like, right? So we can see that even there are products even outside this range which have a lower count, but definitely they are also incurring some higher cost in that case. Now let's go ahead and do some more analysis. There is also another way of doing the same thing with the help of something called as rug plot, RUG, right? You can see this term, rug plot. Now, in order to perform this rug plot, it's quite simple. You can just mark in the same dist plot rug as true. Rug plot also takes a good time. That's the reason I have taken only a smaller subset of data. I have not taken the full data just to avoid saving that particular time frame for us. Now, when you execute this, you can see that the output is exactly same, except some lines which are basically coming up here, right? These are some lines which are coming up. So what is happening? This rug plot is giving us an insight that how much data is occurring here. So as you can see that there are more lines here when my histogram count was very high. Sorry, my distributed density plot value was very high, right? So basically it means that for every entry it's just gonna plot a point. So definitely when this is going to be a lot of values in one zone, so definitely there will be a lot of these straight lines, and that's what denotes your rug plot. So it's basically telling me where the density of the data is too much and where it is too low. That's what basically we are noticing in this particular case. Now going ahead, if you want to remove, let's say, histogram from it, you don't want to see this histogram, you just want to see this distribution curve, you can just say hist is equal to false, and this is going to return you the value with basically without any histogram. Similarly, it's behind the scene when you're running this Seaborn packages, it's all running matplot at the backend. Okay, just keep that in mind. Now what I want to do is, maybe I want to plot all these things now with a subplot format. Now again, a strong recommendation, you have already seen this graph, you already have the data with you, please go ahead and try to do it on your own. It's a very similar step. Do create all these steps, means pause the video right away and start doing it. If after that, please watch my solution. Then after that, you can see that again it have 2 rows and 2 columns. So I want to put the first graph for it. So here you can see that I am keeping up the data in this format. Similarly, here I can put the value 3 if I don't want to represent figure 1, figure 2 separately. I can put the value 3 and 4, and this will also work in SNS plot. So again, we have already seen this how to do it, so there's no issue in this case. Now let's talk about box plot. Now with box plot, what I want to do, again I want to apply it on order quantity, and you can see that this box plot is spread on the x-axis, okay, not on the y-axis, which we are more habitual of watching it, but that's okay. If you want to make it in the y-axis, just put a parameter y is equal to, you can see that here I have not put any parameter, here I'm just saying y is equal to, so it will get turned up with respect to your y-axis, and then you can see that my median value is somewhere around 26 and so on, right? So that's what the value we can see from here. Now let's see, perform some bivariate analysis. Bivariate analysis, again by doing some Seaborn plots, so that we can learn almost both of them. Now in this case also, in bivariate analysis, the difference is, in univariate analysis you only work on one column at a time. For example, you have seen that we were talking about order amount, we were talking about shipping cost, we were not including any other column other than the first column or whatever column is of my consideration. So I was not even bothered about any other thing in that. But when it comes to bivariate distributions, we are going to now talk with respect to 2 columns. So not one column, but 2 columns. So that is going to be the difference in bivariate analysis. So here you can see that I'm creating some sort of joint plot, but I'm talking about 2 columns for my data, sales and profit. Let's see that how my basically this looks like. So when I draw this plot, this is how this distribution looks like. You can see that we do have a scatter plot coming up, and this is basically the histogram for these 2 columns. One histogram will be for profit and one will be for sales, and this is going to just draw both the plots so that you can very easily kind of go ahead and visualize both the thing into one graph. Now you can notice here that the distribution is again very heavily skewed, right? You can see that most of the values are falling in this range. Now what to do in this case? Maybe we can remove some of the points which are kind of acting like an outlier, because as we can see, this value is very huge, and that may be one of the reason this graph is sounding like this. So maybe we would like to remove all these outliers from here. So what we can do, we can just put this condition that profit is less than 10,000 and sales is less than 20,000, which is gonna automatically remove all my outlier points, which we have seen it from those plots. Now when we did that, now my distribution is looking very good, right? Because now you can see that we are getting the scattered plot very nicely in this particular graph. Now one more thing which you can also do it, if you just add another parameter called as hex and add a color, you can notice, and you can see this part, this is just nothing, the same part, we have just put some conditions for it. You can find a very interesting graph, and if you look at this graph is basically telling me between sales and profit. So we can notice here that there are some high selling products which have high sales, but at the same time they are into negative range, they are incurring a profit for me. So maybe these are the products which we would like to avoid. And if you look at this component, this means that these are highly profitable kind of product which we are going up. Here though the basically sales is less, but still the profit is high. So using this graph also we can infer a lot of information. Anyway, for now my focus is not to give you much more analysis from the bivariate portion, because this is just major focus is here Seaborn plot, not bivariate analysis. So we are going to learn all that bivariate analysis section in later section later detail. So we will go in detail and learn all these things while working on a particular good case study. But for now, just get a good idea that how this whole thing is coming up. Now, after that, what I want to do, I have, let's say, a lot of data sets with me. So these data set is related to, let's say, bitcoins and various other currencies what we have. So you might have heard a lot that if one currency is going down, let's say if US dollar is going down, maybe Indian rupee will also be impacted, right? So sometimes we do have currencies being impacted on one over other. Similarly, if you talk about, let's say, share market, this do happens a lot that if, let's say, Samsung share is going to decrease, it may impact Apple share. Like just an example, because they are one of the manufacturer for them. So now in this case, you can notice here that we have called up all the CSV files having all the data. And we are basically, this is my data, you can see up. We have just merged up the data so that we can get all the things together. Now, once we have merged the data, what we want to do is we have taken the main columns which we want from it, and then let's plot a pair plot. Because right now, if you look at this data which we have current dot head, we have lot of columns in it. Now, is it possible for you to visualize multi-dimensional data? No. We can visualize 2D data, maybe 3D data. But how much dimension of this data? 1, 2, 3, 4, 5, 6. There's 6-dimensional data. Now it's impossible for me to create something like 6-dimensional graph right now. So what I can do, there is a very nice technique called as pair plot. What pair plot do is, pair plot is going to basically plot for every two possible columns. Like pair plot is going to plot between close underscore BTC versus close underscore ET. Similarly, close underscore BTC versus close underscore ITC, and so on. For every column with other column, it's going to plot a pair plot. You can see this here. So here when I draw this pair plot, you can see that this is close underscore BTC versus close underscore BTC itself. But close underscore BTC, if we look at this graph, this is going to be with close underscore ET. Like you can see this portions as well if you want to, like close underscore QT, right? Close underscore QT, and this graph is against close underscore BTC. So like this, you can very well visualize now the things in terms of 2D instead of looking at 6D graph. And what's the advantage of doing all this? With this, you can have sometimes very nice interesting pattern coming up. For example, you can notice here, if we go up and look at few of the cases, let me remove some of the part. Yeah, see this portion. So you can see here, maybe this had a very nice linear relationship, right? Because you can see that when my close underscore ET is increasing, most likely my closed underscore DT is also increasing. Some of the part have no relation. The means if it is fully scattered, definitely it have not much impact, because that means that one is increasing, other we can't really say about it, whether it's increasing or decreasing. But for some, we can have some sort of rule basically coming up. So we can always say that, okay, there's a nice relationship between these two graphs, or whether there's a negative or positive relation. So if the relationship is going to go in this direction, that means there's a positive relationship, because if this is increasing, this is also increasing. But if we saw some pattern like this means there's a decreasing relationship. Means if this is increasing, this is decreasing. Okay, so this sort of pattern is what you can very easily kind of get in the pair plots. So this is what we want to basically search. Like you can see here, there's no pattern, right? So there is not much of the impact of one over other. Here we do have a small pattern, here we do have a pattern, right? So this gives a very nice insight that how well these two variables are going to be related. Now, so let's go ahead and see few more things with respect to the same pair plot which we have just discussed. Now this is going to give us a correlation part. Like what do you mean by this? So sometimes, like we have just seen, right, it do happens that if we increase one variable, it do impact your other variables a lot, right? So that's basically is what is called as positive correlation. So sometimes it do happen that my two variables are very highly correlated. So if one is increasing, then second is also increasing. That's called as positive correlation. Similarly, we do have sometimes one is increasing, second is decreasing. In that case, my correlation value is in the negative side. So you can see here that this correlation is nothing but with, now rather than seeing it from the graph point of view, you can get some numbers, and the maximum value will be 1. Now in this case you can see that definitely a variable will be 100% correlated with the same variable name, right? It makes sense. So if I talk about close BTC, definitely the amount it is increasing 100% is going to increase for the same comparison. But you can see that for few of the portions we do have a good correlation, like when we say close underscore QT and close underscore ET, this have a very positive relationship. And if you go back and look at your pair plot, you will see a very nice trend also coming up for it, if you go back and check that. Similarly, you can see even the other values where you are getting a very good correlation, like close underscore ITC is highly correlated with close underscore mon relationship. Similarly, this is very nicely correlated, right? So wherever the value is closer to 1, that means it have a very positive highly correlations of what we can see. If it is a negative correlation, the value will go into negatives. Okay, we will see those things as well when we will move further. Now, so here this is the correlation of matrix, and right now by looking at this it's very difficult for me to visualize this. So what we do is we take the help of something called as heat maps. So heat map is going to print out the value of all these heat maps value for you in form of a matrix, and you can see here that if it is dark blue, that means it have a very high correlation part. So you can see here dark blue, and if it is like yellowish, that means that it have a low correlation. So you can see that 1 is very highly part, so it's more easy for us to visualize. So how we read this data, let's say we can see that 0.79, that means close underscore ITC, and the second part what you have, let's go and check that, what is this, close underscore mon, right? So you can see this particular section again. So when I say this, so means close underscore ITC and close underscore mon. These two are highly correlated currency in this particular case. So that's what you can infer from this. So it's more easy for us to visualize. We can just look at all the blue points where my value is going to be higher, and that's very easy to catch rather than searching in the whole matrix, because right now it was very small data sets for us to get that. So I was able to easily go and look at in the matrix, but if my data set is going to be highly dimensional data, then in that case you can't follow this approach, means you have to go with a different one. Now you might be wondering that where this might be useful. Now I'm pretty sure all of you, when you started your job, you might have come across a scenario where these people approach you and say that, okay, maybe you should invest your money in this particular mutual fund, invest your money in the stock market. These kind of guidance you might be getting from your parents, or maybe some agents might be following you up. Now what they do tell you, one portion of this is definitely saving tax, but the other portion or other side of this is that they tell you that we will assign a manager for you who will put your money in the diverse portfolio. What I mean by this diverse portfolio here, diverse portfolio is that, let's say if there are two shares, okay, who are going to be highly correlated. What I mean by is, let's say if there is a share A and there is a share B. So what is generally observed is that if the share price of A increases, share price of B will always increase as well. So in this case, we should it is always recommended that you should not put your money on both the shares together, okay, because if you will do this, what will happen, that if some loss is going to happen here, then you will face the same loss here as well. So it is always suggested that go with the share C which have no correlation with A or B, right? So then they will be kind of you have a diverse portfolio. This is what basically they do when they say or talk about these terms, that you should put your money in the diverse portfolio. So they do have all their data scientists with them who basically do this analysis, look at the covariance matrix, that which shares are highly correlated or not, and then can give you a very nice insight that these are maybe the shares where you would like to invest, because they don't have any sort of correlation. Definitely they will not tell you in these terms, but this is how you can use this particular knowledge what you have just gained. Okay, so I hope now you are able to relate so many of the learning which we have done to your real world situations as well. In fact, we have not even started machine learning, right? So once we move to machine learning topics, you will start noticing that in fact it will go more interesting in terms of you will notice that we will work on a lot of real world use cases there, and there these the initial part is just called as data analysis. So what we generally do is you get a problem, you clean the data, and we will see that how to clean all of that stuff. Then after that, you do all these visualizations to get some insight of it, do some exploratory data analysis to make sure that all your data is intact, and then basically keep on proceeding in this case. So that's what is one of the thing what we perform there. And here basically this is just a building block which we are learning right now, so that once we move to that stage, it will be much more easier for our understanding at that time. So great. With this, we are of this lecture. We will talk about few more scenarios in the next lecture.